Continuing on with our list of common sedimentary minerals, we are going to talk about the evaporite sequence. So we've already talked about how some sedimentary minerals are formed when water evaporates, water that's saturated with ions. As it evaporates, those ions become supersaturated and can precipitate out as a solid. Calcite is one such mineral. We've already talked about calcite. And calcite is the mineral that starts to precipitate out once about 50% of the seawater has been evaporated or removed. But if that water keeps evaporating, gypsum is the next mineral to precipitate. Gypsum precipitates when about 80 to 90% of the seawater has been removed. So gypsum is a common mineral in evaporite deposits. It consists of strongly bonded layers of sulfate and calcium that bonds parallel to layers of water or water molecules. And this is why it often forms in that columnar fibrous habit. As you know, it has a very low hardness. You can scratch it with your fingernail, but it does have excellent cleavage. We do mine gypsum. It's mainly used for the creation of things like sheetrock or drywall. Now, if that water continues to evaporate even more, the next mineral to precipitate out is good old salt, good old halite. Halite is a sodium chloride, NaCl. It's another common evaporite, and it can also occur in salt domes. So as you should know at this point, halite has a very low density, and therefore when it is buried in the stratigraphic record, it can actually start to balloon up and move up towards the surface because of that low density, creating a salt dome. This is also where a lot of oil and other natural gas, fossil fuels can be trapped. The most extensive use of halite, you might think it's for salt for eating, but it's actually not. It's mainly used in the chemical industry as a production of sodium and chloride, which is the two elements that make it up, as well as hydrochloric acid. So when we use hydrochloric acid in the lab, it's very likely that salt was mined to create that hydrochloric acid. Another type of salt, this is called the potassium salt or sylvite, another very common constituent. It's the last of the evaporite minerals to evaporate out in that sequence that we saw, and it's distinguished from halite by its bitter taste. It's also the chief ore mineral for production of potassium compounds. And just like potassium feldspar has a pink color, potassium salt sylvite also has that pink color. Next up, we have anhydrite. This is a common constituent of evaporite deposits, so it's also found along with halite, calcium, gypsum, and so on. It's often used as a soil conditioner. Next up, we have two pretty ones. We've got chert and agate. Both of these are basically just very, 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 very fine-grained quartz. So just like quartz, their chemical composition is SiO2, but they are microcrystalline, meaning that the crystals are so small you cannot even see them under an optical microscope. Most chert is of a marine origin, and agates commonly form in vugs or cavities, air bubbles, in volcanic rocks, and they result when silica is deposited slowly over time as groundwater percolates through those cavities, through those vugs. And this forms chalcedony, which is again a microcrystalline quartz, and it's a main constituent of agate. Another thing that can form within those cavities, these two, what we're looking at, are microcrystalline quartz, but other things can also form in the cavities, such as just regular old quartz. And when that happens, we call these geodes. Geodes are spherical or subspherical rock structures where the internal cavity, that vug, has been lined with the deposition of new minerals. Quartz is an incredibly common mineral to deposit, but you can also get calcite or chert or chalcedony. You can actually see a little bit of chalcedony here forming just before the quartz. And when these minerals precipitate out in that open area, that void, the outside of that void becomes really hard and weather resistant, and therefore the surrounding bedrock can erode away and you're left with just that round geoid. Okay. Geoids, again, I said they often form in those cavities, those bubbles. The bubbles are common in volcanic rocks. or can even be formed from animal burrows, tree roots, mud balls, and sedimentary rocks, other things like that. Anything that creates a hollow void can cause it, can create a geode. Now, because of this, geoids can be found throughout the world, all the way from deserts to volcanic ash beds to the ocean floor. But volcanic ash beds and regions containing limestone are the most common geoid locations because they tend to have the most air bubbles, or the most bugs, the most voids. And because of this, you want to go somewhere with a lot of volcanism or limestone to find geoids, such as California, Utah, Arizona, Nevada, things like that. We do have them here in Georgia, just not as common.